Hello guys, welcome back, and in today's tutorial I'll be showing you how you can achieve a variable duty cycle using this type of board or any other board which has STM32 chip, and it is programmable using STM32 Q by DA or carrier vision and the like. So I'll be using Nucleo F401 RA, and this is how I have configured my setup, and you can see that I have this potentiometer, so it is reading values from the board will be reading ADC values from the potentiometer. You can see how I've connected it, the VCC connected to one side, grounded on the other side, and taking the analog out pin to the analog 0 1 input pin of the board. So the the period of the PMW signal that I'll be generating will be 1 second, and I'll vary the duty cycle from 0 to maximum, and you know that the duty cycle is T on over period, and let's get started. So I'll create a new project, and I'll select my board. So I'm using Nucleo F401. I'll start my project. I initialize all peripherals with their default mode. So here we are. I'm not going to use the USAT, so I'm going to reset these pins, but I'll be using pin PA5, but not as a GPIO output, but as timer 2 channel 1 output to generate PWM. So I go to timer 2, and clock source, internal clock, and I'm going to select PWM generation. You can see that it is now activated. I'll have my prescale at 1000, so basically because it counts from 0 to 999, and then I'll have my value at ARR register to be let us first check the clock configuration. It is running at 84 megahertz, so the period will be 8399, so that is 84,000, and the pass will be half the initial pass width or pass bits value will be 41,999, so that's basically 4200. So with this you will achieve 1 second PWM signal, and it will be on half of the period and on half of the other period. So from there, go to project manager, give your code a name, call it variable duty cycle tutorial, and I'll be using carrier vision, and from there all the others are good, and then I generate my code. So something else I forgot to configure is the ADC. So I'll go to ADC analog, ADC1, and I'll have my input 0, which is activated, and the parameters are all good. So I'll generate my code again. So there we are. So we open project. So there we are. Go to application, main.c, and you go to the private variables, and I have two private variables, double row value, and I also have double volts. And then from there I'll come here, the main function, and after initializing GPIO and timer 2 and ADC1, I'll start my PWM generation. PWM start, and I'm using timer 2, and I'm using channel 1 of timer 2. So then from there I'm gonna build this code to see what we have. To check for errors. So you can see that our code has no errors. We can maybe load the code and see whether we have the 1 second PWM signal. So when I manually reset, you see the PW signal is 1, so the period is 1. It is blinking after every 1 second. So at this point it is not variable, so we go back to our code, and the first thing I want to do is come out of the main function and declare my function to vary the PWM. So, and first thing I'm going to do here is that I'm going to read the ADC. So I'm going to start the ADC. So, and I'm using ADC1. And then what I'm going to do next is to convert. So I'm using ADC1, and timeout can give it 100, and then I'm going to have my row value here, and I'm gonna cast these into double, and I'm going to get now ADC get value from ADC1, and then from there I want to convert, so I have my votes will be equal to the row value times, I'm going to map the input to 5 votes, so 5 over 40, 95. So after that, I'm going to now to write this value to the CR1 register, and I'll have now volts times so I mapped the period to 5, to a maximum of 5, so the value that I got is 16800. So this value will be every time I vary my potentiometer, shall read and convert this value, and this value will be stored in the CCR1 register. So I'm going to build my code, see whether I have any errors. I can have that as 5.0. So then I'm going to call this function to the main. Going to call it here the main loop, the while loop. So I'm going to build my code again. So you have 0 errors and 0 warnings. So let us download the code. So the code has been downloaded to our board. So I'm just going to perform a manual reset. You can see that the green LED is blinking, and I'm going to vary my potentiometer. And you notice that the duty cycle is changing. So the duty cycle there is almost 0, and let me increase the duty cycle, and you can see now the duty cycle is 1, and if I put it at almost at the middle, you see that T on is equals to T off. So thank you so much for following up with me. Don't forget to subscribe, and for more interesting things to come.